The Booties Void, a galactic ghost town of staggering proportions. Imagine a sphere of space so massive it could comfortably swallow hundreds of thousands of galaxies, a region over 330 million light-years across. Now imagine finding only about 60 galaxies scattered within it. This isn't just a low-density area, it's a profound, unnerving emptiness. Discovered in 1981 by astronomer Robert Kirshner, the sheer scale of the Booties Void, which has been colloquially dubbed the Great Nothing, defied all conventional cosmological models at the time. It challenged the very idea of a homogeneous universe, where matter is supposed to be evenly distributed on large scales. For decades, the why of the Booties Void has been a cosmic cold case. The leading theory suggests it formed from the coalescence of smaller voids, like giant cosmic bubbles merging into a single massive one. But even this idea doesn't fully explain its almost perfect spherical shape or its chilling, nearly uniform emptiness. The Boomerang Nebula, a young planetary nebula located about 5,000 light-years away in the constellation Centaurus, is not just cold, it is the coldest known natural place in the entire universe. Its temperature registers at an absolutely mind-numbing -458 degrees Fahrenheit, which is only 1 degree warmer than absolute zero, the theoretical temperature where all particle motion ceases. What makes this so bizarre is that it is colder than the cosmic background radiation, the lingering heat from the Big Bang itself. Space on average has a background temperature of about -455 degrees Fahrenheit. The Boomerang Nebula has managed to beat the background temperature of the universe. So how can a star, which by its nature is an incredibly hot object, create something so cold? The answer lies in a cosmic phenomenon known as adiabatic expansion. The central aging star is dying, and in its death throes, it's shedding its outer layers at an absolutely blistering speed of over 360,000 miles per hour. This rapid expansion of gas causes the particles to cool down dramatically, just like a refrigerator uses expanding gas to create a cold environment. But the Boomerang Nebula takes this principle to a galactic extreme, creating a pocket of cosmic deep freeze that's a true physics-bending anomaly. It's a shocking testament to the bizarre extremes of the universe and a profound reminder that even the most fundamental rules of temperature can be broken. The Eridanus Supervoid. While it was initially believed to be a simple statistical fluctuation, this cold spot is a massive region, a billion light-years across, that is significantly colder than the surrounding universe, a colossal void of space that is even bigger and more empty than the Booties Void. But here's where things get really interesting and controversial. The existence of a cold spot this large is a huge problem for the standard model of cosmology. It's an anomaly that has an almost a 1 in 50 chance of being a random fluctuation. So if it's not a random cosmic fluke, what is it? A number of physicists and cosmologists have proposed a jaw-dropping theory that the Eridanus Supervoid and the cold spot linked to it is actually the last faint imprint of our universe having bumped into another. That's right, the bruise on the cosmic background could be the signature of a parallel universe. This multiverse theory, while highly speculative, is supported by some string theorists and has been the subject of intense debate. This cold spot isn't just a mysterious void. It could be the first, albeit indirect, evidence we have of other universes existing beyond our own. Fermi Bubbles. For a long time, the center of our galaxy, with its supermassive black hole Sagittarius A SRA, was thought to be a quiet, serene place. Then, in 2010, the Fermi Gamma Ray Space Telescope made a mind-boggling discovery, a gigantic, hourglass-shaped structure erupting from the galactic center. These two colossal lobes stretch 25,000 light-years above and below the galactic plane. This is an explosive revelation of galactic proportions. The Fermi bubbles are composed of high-energy gas and cosmic rays and are emitting gamma rays at an intensity that shocked scientists. The prevailing theory is that they are the result of a violent cataclysmic event that occurred at the galactic center. It could have been a massive burst of star formation, or more dramatically, an explosive outburst from our central black hole. For years, astronomers thought this event happened millions of years ago. However, recent cutting-edge research has turned that timeline on its head. Scientists have now found evidence of cold, dense gas clouds embedded within the bubble's million-degree heat, which should have been vaporized instantly. Their survival suggests that the eruption that created the Fermi bubbles is much, much younger than we thought, possibly just 1 million years old. This means the event happened while early humans were just beginning to walk the Earth, a stunning new perspective on our galaxy's turbulent past. But the real oddities aren't just in what we see, they're in what we can't. The bedrock of our cosmological models rests on the existence of dark matter, a mysterious substance that makes up roughly 85% of the universe's mass. Without it, the gravity of stars wouldn't be enough to hold galaxies together. The Dark-Matterless Galaxy. This galaxy, named NGC 1052 DF2, is an ultra-diffuse galaxy that appeared to be almost completely devoid of dark matter. It was a cosmic impossibility, a galaxy that, according to our most fundamental theories, shouldn't exist. This discovery ignited a firestorm of controversy in the astronomy community. Scientists scrambled to either confirm the discovery or find a flaw in the data. The initial findings suggested that the galaxy's stars could account for all of its mass, a claim that flew in the face of the standard cosmological model. But as with all great mysteries, the plot has thickened. More recent studies have questioned the original measurements, with some arguing that the galaxy's distance was underestimated, which would change the mass calculations. Others suggest that while the galaxy may not be completely devoid of dark matter, it has a lopsided distribution of it. The debate is far from over, but the existence of this impossible object has forced us to re-examine our most basic assumptions about how galaxies form and what dark matter actually is. It's a reminder that what we believe to be true might just be the first and most easily broken rule of the universe. Hyperion, a massive proto-supercluster of galaxies, is the largest and most massive structure ever found in the early universe. Its immense mass, over 1 billion times that of the Sun, is a serious problem for our current understanding of cosmic evolution. Found just 2.3 billion years after the Big Bang, Hyperion is so large and complex that it shouldn't have had enough time to form. It's like finding a fully grown adult in a nursery filled with newborns. The discovery of Hyperion, which was named after a titan from Greek mythology, is a shock to astronomers who thought that such enormous structures would require billions more years to slowly assemble under the force of gravity. This has led to intense research into how such a gigantic structure could have come together so quickly. Its existence challenges the standard cosmological timeline and forces us to consider that the early universe might have been far more active and clumpy than we ever imagined. It's a true cosmic anomaly, a giant that shouldn't have been born, and it gives us a rare glimpse into the chaotic, high-speed construction phase of the universe. The double quasar, also known as the twin quasar. They believed they had found two identical quasars in the same patch of sky. They were at the same distance, had the same properties, and were far too close together to be a coincidence. But the shocking truth was that they were one and the same. The cosmic doppelgangers were a single object whose light was being bent and split by the immense gravity of an intervening galaxy. This jaw-dropping phenomenon, known as gravitational lensing, was the first observational proof of Einstein's theory of general relativity. The quasar's light had traveled for billions of years, only to be warped by the unseen mass of a galaxy cluster, creating a cosmic funhouse mirror that gave us two distinct images of the same object. This wasn't just a beautiful accident, it was a powerful tool. By studying the light from the two images, astronomers can measure the mass of the lensing galaxy and learn more about the structure of the universe. In a completely mind-bending twist, the effect of the lensing is so precise that astronomers have even used it to hunt for planets in the lensing galaxy, using the slight delay in light between the two images to detect a planet-sized object passing in front of it. A cosmic illusion, a confirmation of a century-old theory, and a tool for hunting invisible worlds. The double quasar image is truly one of the universe's most surreal and useful phenomena. The living fossil galaxy is a type of galaxy that is a cosmic time capsule. In a universe where galaxies are constantly evolving, merging, and changing, these are the few that somehow stopped. They formed billions of years ago, and then, for reasons we still don't fully understand, ceased to produce new stars. They are the same today as they were over 7 billion years ago, a static relic in a dynamic cosmos. These living fossil galaxies are like perfectly preserved specimens from a long-lost era of the universe. They are dense, compact, and completely inactive, a stark contrast to the sprawling, spiral galaxies we see today. The mystery behind their formation and stasis is a major area of research. Some theories suggest they were starved of the gas needed to form new stars, while others believe they were the unfortunate victims of an unknown cosmic process that shut down their star-making machinery. They provide astronomers with a unique opportunity to study the early universe and test our models of galaxy formation. By examining these ancient, unchanging objects, we can gain a clearer picture of what the universe was like when it was young, and a chilling hint of what can happen when cosmic evolution just stops. From a vast, terrifyingly empty ghost town in a frigid nebula that's colder than nothingness, to a possible multiverse bruise in an impossible galaxy with no dark matter, the cosmos is not the neat, orderly place we once imagined. It's a chaotic, illogical, and truly bizarre place, a realm of shocking extremes and mysteries that we're only just beginning to scratch the surface of. These aren't just oddities, they're cracks in our understanding, glimpses of a truth that is far stranger and more complex than we could have ever conceived. And they leave us with a final, lingering question: what other impossible secrets are out there, hiding in plain sight, waiting for us to discover them?